Now let's take a look at the MPS and the exchange buffer itself. So first thing, let's start the MPS. So I'm using the 2021.3, this version. Okay, this is the one I opened earlier. So the one we checked out, cloned. So as you can see, this is MPS, the main UI. There are two kinds of projects: the language and the solution. The language, we define everything about every language, and then we use the language in the solution. So solution basically they are protocols, but they always use this EB language, exchange buffer language, and this EBLAN CPP and the EBLAN Python. I defined the rules of how to generate the code from language, EB language itself. So like here. I defined many tabs. So the literals, primitive tabs, the statement, everything. So this is so the message members, including the constructor, the variable length member, and the fixed length member. Like let's take a look at, for example, this is one variable length member, class member. So in CPP, C++ code, we're going to generate the optional ref template object. So basically, this is a proxy to manipulate the underlying data. We also can see the B field. The B field, this loop and the copy src means we're going to loop all the members and use their rule to generate the whole B field. So every B field member would, like we use this rule here actually. So to eventually we will build the whole B field. So etc. This enum, and also we should have enum member. Enum member is a integer key value pair. Okay, so let's go back to the LME. So the debug terminal actually is implemented right now only for LME, the one I'm testing. Let's take a look at what's defined in this enemy particle. Okay. First thing, primitive alias to import or use or introduce the primitive types into this particle. So these are integer primitive types. We can define a min, max, now value. So like this now value is it's defined in the spec file. So we have to use the same here. And like a string, a fixed length string is 5 bytes long, with the padding is 0. Okay, this 0, you see this double quotes here, but this is not like a C++ style string. We just code this value. This value is a ASCII value 0. So it's like in C++ that's a \0. We have so many different fixed length strings which will be used later. So this is a float decimal. If no, min, max, now, then the exchange buffer will generate the default value. Like because this is the size is 4, precision is 3. Right, this is a sound and Little India. This is a this is enum of the message type heartbeat in logon logout, the new order single. Many enums, and then this is a message header, the header file. So every message starts with a message header. This is the default value of this field. The start of a message should be the 2, and the message lines, message type, everything here. So so logon message, actually all the message except this message header, they all inherited from the message header. So in the message layout, message header is the first part of the message, then the rest parts will be this logon. So from the spec, actually the presence map, for presence map, actually in the spec that's only one presence map, and it's like 32 bytes long. So but here we use 8 bytes. That's one uint 64. So we put 4 presence map here to match the description of the spec. Technically, actually, we should put this presence map into this message header. Then I don't have to repeat all the definitions in each message. But there's a problem of in the Python implementation. So the message header and the real message, they are from 2 layers. there's some difficulty to access this message header layer in the this message itself. So maybe later that might be a change. But now I just put all the present map fields into the message itself. So this is the optional type. So optional type, it has a type itself, and there's a presence map, and also the position to indicate which bit is the flag of this type of this field. If this bit is 0, that means this field should not be included in the message. Then we can use this way to calculate how many fields in one message, and the length of the message, etc. So here actually that's a constructor. So we pass this log on because we call the base class constructor. We give log on as this to initialize the message type. Then later when we we instantiate object, we don't have to set the message type anymore. That's a typical usage of a constructor. So it's been implemented here. Besides the data members, also the constructor, the base initializer values. That's the constructor in the derived class. So use this value to initialize the base class. Okay, this all the different messages. For some of them, we can also set a default value of a member, and also we can give it a fixed tag. Fixed tag later we can use it to we're dealing with the binary protocol. We can do some sort of mapping, like the quantity. If it's a quantity, maybe I think I have some later. Let's check the new message. Okay, so like this clan already, this is tag 11. So technically it can be implemented in this way. For the field named clan already, we put the fixed tag there. So in this case, it's more easier for some of the tools to pass the message. Like if we want to create KDB, query the data, we don't have to remember the different names of different protocols. Like that one is a quantity, and this one is called order quantity, etc. We just use the standard fixed tag name as a field. That's more easier. Okay, so you see, previously we introduced the primitive types. Here we use it to define a message member. Also, this side is the enum value we defined earlier. So we declare this member is it's a side, and its type is the enum side. Okay, all right. So what's the difference of this optional and the float. The optional means there's the bit to indicate if this field exists or not, but a floating member, that means this member must exist, is a checksum. Checksum, every message, the last member should be checksum. And because you know, all those fields, optional fields, are calculated you know, dynamically on runtime, so we can't just simply put simple like this fixed lines member after the optional, because actually we don't know when you know, where this where is the start offset of this message member. So we have to use the floating tab here. So maybe some of the optional fields are missing, but no matter how many left, then it will be after the previous you know, exist ones. So that's a floating. Okay. So in this way, we define the different types, primitive types, enum or besides, or you know, here I think there's also repeating group. Okay, so this is a repeating group execution report. In execution report, so this execution this repeating group is also optional. It could, you know, it's controlled by this bit, and if it exists, the repeating group itself, it has like a number of likes. This would control the how many execution report like entry here. If that's 2, then there will be 2 execution report like entry after this number of likes field. So for this tab, this tab is a fixed length of tab. You know, here, because that's a member, so it should not inherit it from the method header, because you know, that's a embedded message tab. So this is like a block. Okay, after we define all those basic types, and then we use those types to define a message. It is very similar, you know, like a C++. We use some primitive types. We define some classes, and we use the classes or primitive types to define a more complicated classes. So that's you know, mapping. Eventually, this message will be mapped to execution report class in C++, and it provides many member functions. We can use those functions to set the value of this message. Okay, let's take a look at the generated file. Okay, now this is a Python code. Actually, we can check here. You know, here is the one thing I want to mention. Actually, I mentioned here in the non-issue. So right now we can't generate the C++ and the Python code together. So maybe it's because some of a wrong setting of a plain text gen or some bug in the plain text gen plugin. The workaround is each time we use different folders to store the generated file, because when we rebuild, all the files previously generated will be cleaned. So now it's Python, we need to use the C++ CPP folder. We want to generate the C++ code here. So we change the directory. We also need to change the generator. So now it's a Python generator. We should use a C++ generator. Then now let's see, preview the generated code files. So this is the using declaration to define or alias the type of those types with this is the little Indian so the template class. There are many template parameters here. Also fixed length string. This is the length of the message, and also the padding of the message. This is 0. ASCII is value 0. So this is the enum. Enum actually will be mapped to a macro. So for the macro, it has this as an enum name and also this enum value. The macro itself also provides many useful functions, like a build from the enum, the build from the underlying int type, or get the string representation of the enum, so which can be used while decoding the message, etc. So this enum definitions. Okay, the message will be mapped to or translated to the struct. So all this is a header. Header is a fixed length header. So it has so many different types of members. So begin, end, size, length. So for the fixed message, this is easy, right? The length is just the size of this message, right? The begin plus the size of the message is the end. So here, the generated the operator output, right? So we can use this operator to decode the message to get a string representation of the message. Let's take a look at this logon message. Then all the optional fields will be converted or translated to optional ref with this tab, and this is the so presence map type, right? This is a type of a presence map. So every optional ref, so actually we will call this function. It returns one proxy object. It's an optional ref. So we would set the begin begin of this optional ref and the end of the optional ref, because in case this optional ref has a a zero length, this all the begin and the end can also be correctly calculated. But we just need to remember we should set the values in sequence one by one. Otherwise, that will be a problem. So this is a typical way we use. We set the variable length member class members. Okay, the similar thing here. Okay, then let's we can do some test here. Let's see, we open one. Let's see, Millennium particle. Let's see. Maybe let me show you. Yeah, I'll use this somewhere else. So let me do some tests in this sandbox. Sandbox, we can do whatever we want to here. That's not a part of any particle. We just try anything here. Okay, here, regarding the T7 particle and the SBE particle, Euronext SBE particle, we can use this way. So if we want to, like these two projects, use the same way to, for cache. This is the T7 cache. That's a very long particle definition, and also the derivative. So let me show you how to so automatically generate the T7 and the Euronext SBE message. So here there's a button we can select. Oops, no, not here. So we can download this file from the Eurex website. So here it has two files, one for cache, one for derivative. With this way, we just need to open it, and this exchange buffer would pass that file and construct the AST tree. This is the one particle is one abstract syntax tree. So everything is generated here. So like a primitive, different enum tabs, and I think later there will be the repeating groups, and also the message itself. These are messages, right? Yeah. So this is a T7. So we should clear it, and then let's say for the SBE, we use the same way. So this is the SBE 319. That's it's a Euronext SBE message. So also the file will be defined. The whole protocol, the types and the messages. Yeah. This is we can automatically generate two kinds of T7 and SBE message. Euronext SBE. So then let's see. Let me show you how to do the let's manually create a protocol file. So let's say the first thing we want to have import some primitive types like primitive type alias char equals so here when we press something, that will be you know, the hints and the tips, and we can use that to auto complete the editing, like int 8. Here, you know, we use the control and the space, we can get a list, all available list, right? So here, because it's uint 8, right, we choose uint 8.1, so it's quite convenient. Then let's say we define order type enum. Order type is, the name is called order type. Its underlying int type will be u int 8. Right. So for the enums, this type is we can use the underlying int type directly. They don't have to be anything of this thing, right? Because the enums, we know the restrictions, and also the Python and the C++ has a support of those underlying types. So the enum underlying type doesn't have to be from the imported. We can use it directly, like if we use control space, we get the list, they are all the int primitive type, right? Then we can, like, order type, that will be, we will give a name like a market. So here, if we give it a value, then that's fine. And also we can, if we input something not the numbers, like a, then it will be automatically coded. Right, that's there's some code to generate a single code directly, but if we input something else, you know, this is not a char, so it's like some sort of string, but string is not allowed for a enum because it's a underlying type is a int, so this also will be checked, right? If let's say some other thing, you know, anything, this is also invalid. There's a check here. So let's say if market 1, like a limit 2, stop order 3, etc. That this is a very simple definition of enum. It has some checks there. Alright, let's see. Also, we can define another one called the enum. Explicit type. We can use a char, right? And the new equal. You know, here is a problem. If we want to input a character, but that's a number, actually there's no clue for the EB buffer to detect. So we need to input like some character and get the single code, and then you know, change the value, right? And though partial fill, like a p fill. Fail 1, right? If fully fail, oh sorry, fail. If we type 2 here, but that's a number 2, not a character 2. So we have to, make sure it's a character. Like this is a EC type. The enum, let me try one. Let's see if we have like a B field. Let's say the B field actually we use the enum to construct the B field. Let's say we have okay. Let me create something. So it's called client ID type. It's new int 8. Also, it's like a non 0 from 1. I'll go to person 3, and this is a clamp ID type. Oh, and we need another investment decision maker. Also underlying it's a uint and non 0 from 0 1. I'll go to person 3. Actually, they are very similar and exactly same actually. And also the execution decision maker type. Also uint 8 non 0 from 1. I'll go to person 3. So then we can create a bit field. The field party row qualifiers. So its type is uint8. Actually, for all those types, they should not larger than the final B field, because actually they are only the parts of the B field. So we can define the first part. Actually, like let's say this value 0, 1, 2, 3, we can use 2 bits to represent 4 values from 0 to 3, right? Then this is a clamp ID type, right? Default none. The last is 2. And another enum, we can choose ID empty, and the default is we can choose, that's values of the ID empty. Default always none. And the last one is also ID empty. Previously this is the ID empty, and also none, and the 2. In this case actually this is a 1 byte. It has 8 bits, right? We use the 6, so from these 2 bits, 2 more left. But that's defined in the exchange spec. The rest of the 2 are not used, so we don't have to define the rest of 2 bits. This is the B field, like a first. Okay, let's see how to see. Person, sorry. Like so in this case, these 2 2 bits. That's for client ID, and this 2 bits. That's for the IDM. 1, 2, 3. Sorry, another one. 2. From 0 to 7, right? This 2 for the client, IDM, EDM, 2 more left. So when we there is a very good API or members for the bit field. We can easily set those bits. We don't need to use the bit operation. We just set the different enums. It's very convenient. So this is the bit field, right? And then let's see. Let's define a little bit more. Parameter alias string 20. Fixed string length 20, right? So then that's it. That's a fixed length string. We can define a message. Message name, let's say new order. New order. There's no base class. So then here, when we use a key control space, there will be some. The first level is the tabs of the members we can create. This is a base initializer. It's used in the derived class to initialize the base class. So in our case, we don't need it. And the block is a repeating group of block. The constructor is used in the base class to take the value from the derived class to initialize the member of base class. This is the entry. Entry is the normal fixed length members, and the floating is I introduced a little bit earlier. It's very similar to optional, but it's always true, always exists. So then optional is a optional field. Use a bit presence map to indicate the presence of the value. So in our case, so we just need to like a control space and E as entry, and then as a control space again, we can select all the defined the types previously to let's say if we define order type first type. This is the order type, and we also can define another one. It's also entry, and its type is string 20. Like then it's client order ID, and then entry. We need a bit field here. Party row qualifiers. Okay. When we also can define the default value. We just use the space and then control space. We can get an optional component here, default. For the default value here, actually there's no any code to check the value, but now maybe I'll add that later, but now there's no check here. So basically we need to give it a, if it's a enum, we need to give it a correct enum number, enum value, order tab dot, it's a order tab dot new order tab, so mark it, right. Yeah, we also can put a fixed tag here, at least 40. Right, so how we define a message. Okay, alright. Let's see some other tabs. If I want to define like header, okay, let me define a message tab. Usually that's message tab. New. Let's see, this is a message tab. Also let's be it's 32. Then call it a message last. This should be int 32 message length and message type, and also here we create constructor. A constructor is only for the message type. It's only take a value of the enum. We should use this. So that's for all the particles I've seen so far. So we defined a constructor here. Then here we can define a base initializer, and then we should give it header here. Then here we can pass the value. Then that will be the new American, so the value, the valid value of this message type. So that's a constructor and a base initializer. And then okay. Let's see. I'll create the unlex. I'm going to create a repeating group. Then we use a block. The type would be a little bit tricky. We can use a string. Normally it's not string, but the counter we can select. Right, it will search all the integer type within the current message. Like this is lex, so very easy, right? And also we can create like a presence map. Also use integer unit 8 p map, and then can create a floating. The type is also string. Oh, sorry, it's not floating. This should be optional. Optional. The type is string 20 presence map. We need to select the correct. It's this p map position 0, and then yeah, that's